All right, starting lesson 6.2, ratios and proportions. Now, a ratio is a comparison of two quantities. The ratio of quantity A to quantity B is most commonly represented as a fraction. The ratio can also be represented as A colon B or A to B. Ratios are usually expressed in simplified form. For example, the ratio 5/10 or 5 colon 10 is usually simplified to 1/2 or 1 to 2 because both of these numbers are divisible by 5. All right, so example 1, the perimeter of a rectangle is 40 feet. All right, we have a rectangle. The perimeter is 40 feet. The ratio of the width to the length is 2 to 3. So the ratio of the width to the length, it's 2 to 3. All right, or 2 over 3. Find the length and the width. Okay, now, the important thing to understand here is that the width is not 2 and the length is not 3. All right, whatever the width and the length are, when you find the ratio of them, it reduces to 2/3. Okay, so there's some number here, x, 2x and 3x. All right, and the reason why I'm using x for both is because that's their common divisor, some value x. All right, they cancel out, or they divide evenly into both of these original numbers here, and we end up with 2/3. So what I really have for w is 2x width is the shorter length, and the length is 3x. All right, so this is the key idea behind understanding how to do these problems. So here I have 2x, the other side is 2x, and this is 3x. And we're talking about perimeter here, so I know all these lengths add up to 40. So I have 2x plus 3x plus 2x plus 3x equals 40. And then I end up with 10x equals 40. Divide by 10, and x is equal to 4. It says find the length and the width. All right, so w is equal to 2x, so w is equal to 8. And the length is equal to 3x, so the length is going to be 12. Done. That's all there is to it. All right, for part B, the area of a rectangle is 108. Okay, now the ratio of the width to the length is 3 to 4. All right, width to length, 3 to 4. And we now know that from the explanation in the previous example that this is going to be 3x and this is going to be 4x. All right, find the length and the width. Okay, well this is 3x, this is 4x. I'm working with area, so area of a rectangle is length times width. So I'm going to have 3x times 4x is equal to the area, which is 108. So I end up with 12x squared is equal to 108. Divide by 12 first. X squared is equal to 9. I take the square root of both sides. Don't forget to introduce the positive and the negative. And x is equal to positive negative 3. Now I can't have a negative length, so I'm only worried about the positive scenario. X is equal to 3. So now what is my width? What is my length? My width is going to be 9, and my length will be 12. Done. All right, for example 2, the measures of the angles in a triangle are in the extended ratio, 3 to 4 to 8. Find the measures of the angles. Okay, well we can't write this extended ratio as a simple fraction, but this is how we're going to express it. We have a triangle, and the extended ratio is 3 to 4 to 8, so it's 3 times some number, 4 times the same number, and 8 times the same number, all right, because they all have to have a common divisor when you simplify the ratio. All right, now, so I'm going to call this here 3x, I'll call this 4x, and I'll call this 8x. Well, what do all the angles of a triangle add up to? They add up to 180. So then I have 15x is equal to 180, and divide 15, and x is equal to 12. Now it's asking find the measures of the angles. All right, so I have to plug x back into each one of these here. So I have, for the first angle, I have 36 degrees. For the next angle, I have 48 degrees. And for the last one, I have 96 degrees. Done. All right, for part B, the measures of the angles in a triangle are in the extended ratio 1:4:7. Find the measures of the angles. Okay, same idea. I have a triangle. This is my extended ratio. My common divisor for all these is some number x. So this is 1x, 4x, 7x. All right, they should all add up to 180. Okay, so I have 12x is equal to 180. Divide by 12. And x is equal to 15. Okay, now I take my x value and I plug it in. So I end up with 15 degrees, 60 degrees, and 105 degrees. Done. All right, now the equality of two ratios is called a proportion. All right, for example, if the ratio A over B is equal to the ratio of C over D, then the following proportion, this is a proportion, can be written. All right, example 3, solve the proportions. Important note, the first step in solving a proportion is to cross multiply. All right, so a little tip here, proportions can be made easier to solve by first simplifying the ratios. All right, so I could cross multiply immediately here in part A, but I'm going to divide the top and the bottom by 3. So I have 3/5. That keeps my numbers smaller, which makes the math easier. You do not have to do it that way. That's just one way to do it. So here I have 3x is equal to 30. Divide by 3, and x is equal to 10. That's all there is to it. Here I'm going to cross multiply. So I get 4y is equal to 8 times y minus 3. I get 4y is equal to 8y minus 24. All right, subtract 8y. So I have negative 4y is equal to negative 24. So divide by negative 4, and y is equal to 6. All right, cross multiply here. I have 4s is equal to 10 times s minus 5. Cross multiply, or not cross multiply, distribute. So I have 4s is equal to 10s minus 50. Subtract 10s. I get negative 6s is equal to negative 50. Divide by negative 6. And I get 50 over 6, which is the same as 25 over 3. And that's what s is equal to, 25 over 3, or 8 1/3. Done. All right, for example 4, the ratio of two side lengths is given. Solve for the variable. All right, so they tell you what the proportion is. EF over FG is equal to 4 over 5. All right, well, what is EF? EF is y plus 7. What is FG? FG is 40. All right, so it's just like the previous examples. You're just setting it up. So I cross multiply here, and I get 160 is equal to 5 times y plus 7. Distribute. I get 160 is equal to 5y plus 35. Subtract 35. All right, and I get 125 is equal to 5y. Divide by 5. And y is equal to 25. Done. Okay. All right, for the next one, I have SU over ST is equal to 4 over 1. SU is equal to 3m plus 6. And ST is equal to m, 4 over 1. So I cross multiply. 4m is equal to 3m plus 6. Doesn't matter what order you do it in. So I subtract 3m, and m is equal to 6. Done. Alrighty. Two gears, gear A and gear B, have a gear ratio of 1 to 3. Okay, so here I have a gear. Very poor example of a gear. Alright, those are two gears. Alright, so the gear ratio is 1 to 3. Gear B has 24 teeth. Alright, so this is gear B teeth. This is gear A teeth. Alright, so reduce this to 1 over 3. So I have 1 over 3, and I'm going to call this A. On top, I know the number of teeth for gear B is 24. Alright, so let's figure out the number of teeth that gear A has. Alright, 3 times A, then I have 24. Divide by 3, and A is equal to 8. Gear A has 8 teeth. Done. Alright, going on to the next problem. Alright, so for example 6, it says the ratio of the corresponding side lengths of triangle QRS to triangle VTU is 3 to 1. This is the key pieces of information here. So find the unknown lengths of both triangles. Okay, the key ratio is 3 to 1. We're going from QRS to VTU, the big triangle to the small triangle. So I have QR for the big triangle, that's the hypotenuse, but I don't have it for the small triangle, that's TV. Alright, so there's a simple setup. I cross multiply, and I have 3 TV is equal to 15. Divide by 3, and I have TV is equal to 5. Okay, so TV is equal to 5. Alright, let's figure out QS. So I have 3 to 1. Alright, now going from the big triangle, I have QS over, what does QS correspond to? QS corresponds to VU, and VU is equal to 3. So once again, I cross multiply, and QS is equal to 9. Alright, simple as that. We have one more to solve for, though. Alright, I have 3 over 1 is equal to, now I'm going to try to find SR. SR corresponds to UT. So UT is 4, so I cross multiply, and SR is equal to 12. Alright, that's all there is to it. If you have any questions, please make sure to ask. Begin the assignment.